So our fifth contestant of the evening is Katie Hassell. Katie, the stage is yours.
Hello, I'm Katie and I'm a spacecraft thermal engineer, which basically means that I get to work on plenty of shiny things. This specifically is a spacecraft thermal blanket, also known as multi-layer insulation, and that's because it's got multiple layers in it. Nice, easy naming. So typically this would have 10 layers of aluminium foils. Each one would be less than 0.5 millimeter thick. If we're working in really high temperature environments, so over 250 degrees C, you'd more likely be using titanium, because that requires much more energy for it to start and achieve that next 1 degree hotter, and maybe we'd be using 20 to 30 layers of foils instead. So, blankets are ace because they're so shiny. That is the best part of my job, is making things shiny. The joy of shiny things is that it's going to reflect lots and lots of light. Heat travels as light. In spacecraft, we're dealing with two main wavelengths. We're dealing with infrared, so what me, you, pretty much all electronics units are going to actually emit in, and we're also dealing in ultraviolet wavelengths, which is what the sun emits in. So the light, either from the sun or from the inside of the spacecraft, is going to contact with the surface of the blanket. 90% of that heat will be reflected away, either out to space, or if it's coming from the inside of the spacecraft, it will be reflected back into the spacecraft itself. That 10% is then absorbed by the next foil, by this foil, which will in itself get hot. If the next layer of foil, if it was in full contact, the heat would move straight through the blanket really rapidly. What we do is that we have a mesh in between the two layers so that they're not in contact. So we're only looking at radiative exchange between the different foils. So we're losing heat at each little layer all the way through the blanket. So on the external surface of a spacecraft, if it's facing the sun, you could have a temperature of around 180 degrees C. This is in Earth orbit. But the side that's facing deep space could be at minus 180 degrees C. So very hot, very cold. And yet the spacecraft, the structure itself will be more around 50 degrees C. So they're really effective. They're not that effective on Earth because convection gets in the way, and so that's why space environment can be much more friendly when we're trying to look at controlling temperatures. And that is pretty much it for shiny spacecraft.